So now that we've talked about the overall structure and functionality of the ImageStreamGang case study, we talked about some of the patterns that are involved. We visualized some of the data flow through the different portions of the pipeline of different intermediate operations and terminal operations and so on. It's finally time to get down to brass tacks, which is the source code. And hopefully by the time we get here, you have a bigger picture view of what's happening, so the source code will make more sense. So we're going to focus on the implementation of the process stream hook method in the ImageStreamGang parallel.java file, which you can see at this link once I upload the slides. First thing we do is we get the input. So get input is something that comes from the StreamGang framework, and it gets the list of URLs which are either given to us by a user on some kind of GUI, or reading from a file, or reading from the command line, or wherever we get it from. We then convert that collection of URLs into a parallel stream. So we have a stream of URLs, which, as you probably recall from our discussions, this will use a splitterator under the hood, which will split up that array, or that list, I guess in this case, into parallel chunks using the array list splitterator, and that will split right down to the atomic sized elements. And so those things will then be used to run in parallel, as we'll see, once the terminal operation is hit, of course. We then go ahead and use the filter intermediate operation to get rid of images that are already downloaded and cached. And remember that filter has the property that can return less than or equal to the number of elements in its input stream. So the output stream could have the same number if nothing had been cached, or if there had been some things cached, it would return less than the input. Or if they were all cached, it would return an empty stream, and everything else below would be ignored. This is how we do the URL cache check. We basically go ahead and check to see whether or not we've already downloaded anything that has that particular filter applied. And so this uses a stream with the any match terminal operation, which will then go to check to see whether the file has already been downloaded. Here's the URL cache method. It tries to open the file, and if the file already exists, then it's been downloaded before. If the file does not exist, it has not been downloaded before. There are other ways to do caches. This is by no means the best. The right way to do it probably would be to use features that are built into HTTP, where you have these concepts of max ages, and you can cache images for a certain amount of time, and if the time has elapsed, then you download the new version, that kind of stuff. But this is just something simple to demonstrate really how to use filter. That was the whole point of this. We then go ahead and will return an output stream consisting of the images that were downloaded from that were not cached. And so you can see here that map has the property that the number of output images maps the ones that are input. And you can see here we're going to apply this method called blocking download. So that's a method reference that's passed to map. So for each non-cached image URL, we're going to call this method. And this method is very clever. It uses a helper class here called blocking task call in managed block in order to download the content from the server and convert it into an image, because it comes back as an image. And what's really important to understand here is that call in managed block is a wrapper around the managed blocker mechanism that's built into Java Common Fork Join, into the Java Common Fork Join pool. And that will add additional threads to the Common Fork Join pool to compensate for blocking operations. So the nice thing here is if we have lots of images we're downloading, the threads in the Common Fork Join pool will temporarily expand, thereby getting better utilization, and then they will contract over time as things are not needed. And this kind of gives you a sense, a little formula that you could read about here if you want to, that talks about how to compute the number of threads you need in a thread pool if you have waiting time that's a certain amount of time. What we get back here is going to be essentially a stream of images, and then we're going to go ahead and apply image filters to process those images. And this particular map operation, for reasons you'll see in a second, is going to apply it's going to end up generating a stream of streams. So we're going to get back a stream of streams here. The number of elements in the stream, because we're using map, will be the same as the number of input elements. So the output elements will match the input elements. This is where you would like to use flat map, but as we've seen before, flat map has those weird quirks we talked about before that make it inappropriate for this particular use case. Here's the apply filters method. You can see what it does is it says for every filter that we have applied, these are called transforms in your program, but same idea. For every filter we have in parallel, apply the filter to the image and then return that as a stream of filtered images. So that's what this is doing. And then what we get out of that, of course, is a streams of filtered images. And then we use reduce and stream concat to manually flatten that stream of streams to filtered images into a stream of filtered images. And that's the parallel way of getting flat map, because flat map doesn't do what we would like. We would normally want to use flat map here, but because of the quirks we looked at before, it doesn't work in parallel for some strange reason. You can read more about that here if you want to learn more about the underlying issues. As I had mentioned before, reduce returns an optional, so we have to handle the case where the stream is empty. The stream might be empty here, actually, if it's the situation where all the URLs we were trying to download had already been cached. So that's a reason why we need to put that check in there, if not just for the obvious syntactic reasons. And then the final thing we do is we collect everything up into a list, and that will then, of course, trigger the intermediate operations, and we store those in a list. And that'll be a list of downloaded, filtered, and stored images, and then we can print out the number, and they'll be available for being displayed.